In this section, we are looking at data displays. In the first few warm-up problems, you already spent some time reading some circle charts and histograms and stem and leaf plots, so let's look at a few more. The number of rounds of golf played by each golfer of an amateur golf association is shown in the chart below. What is the average number of rounds played by each player? So the rows are the rounds of golf played, and then the y-axis is going to have the number of golfers. Now, they don't have another key for us, so we have to assume that each of these dots is one golfer. So that means 1, 2, 3, 4, 5 golfers played 1 round of golf, and 2 golfers played 2 rounds of golf. Because we want to know the average number of rounds played by each player, we need to multiply each of those 2 golfers by 2 to get a grand total of 4 rounds of golf were played in this section. Over here we have 2 golfers, each played 3 rounds, which gives us a total of 6. Here we have 3 golfers, each played 4 rounds, so that gives us a total of 12. And lastly, we have 5 golfers played 5 rounds, which is a total of 25 rounds. So the sum of all the rounds is going to be 5 rounds and 4 rounds and 6 rounds and 12 rounds, and 25 rounds of golf were played, which is a grand total of 52 rounds of golf. Now if we count up how many golfers we have, we should have 17 golfers, 5, 10, 13, 14, 15, 16, 17, so 52 divided by 17. Now when they told me express my answer to the nearest whole number, that cues me in that this is probably going to be a decimal, but I'm not super worried about which one it is. And I know that I'm going to get 3 times 17 is exactly 51, so I have 1 remaining, 1/17 left. So nearest whole number is going to be 3. The average number of rounds played by these golfers in an amateur golf association is 3 rounds. And really looking at our chart alone, we should have probably been able to take a pretty good guess that it was close to 3 because of how close to symmetrical it is. The chart below was created from the results of a radio station survey. What % of the males surveyed listened to the station? This is not just a direct, you read the graph, the answer is 39%, but it can be misleading that that's the case. If we look at the specific question, they're saying what % of the males surveyed. That means our total in this fraction is going to be the males surveyed. Well, they didn't just ask males, they asked males and females. So because they asked more, we need to change our total number to not 100%, but 52%. Our total is out of all 52% who were asked, and if you think of this as 100 people, that might work well as well, but out of the total 52% of people who were asked, how many of them listen to the station? Well, listening to the station, that's 39% of the 52% they asked, right? The other 48% were not of the males, they were female, so they don't count in this survey. So if we look at 39 divided by 52, that is going to be exactly 75%. So 75% of the males they surveyed listened to the station. Next, we have, according to the graph, what is the mode of the number of pets among the families surveyed? So you want to be really careful here because mode initially looks like it's going to be 1. That's the biggest column, but that is misleading. We have to read this chart a little more carefully. The y-axis says numbers of families with at least n pets, which means that about 500 families have at least 1 pet. So if 500 families have at least 1 pet, and let's estimate the next one to be about 450. 450 families have at least 2 pets. Well, there's some overlap here. 450 of these people were counted twice. They were also in this group. Because these 450 people who have at least 2 pets also had at least 1 pet, we can actually figure out a pretty good estimate of the number of families who have exactly 1 pet. And that would be this difference right here, about 50. So about 50 families surveyed have exactly 1 pet. Well, let's look at the rest of these then. The number of families with at least 3 pets was also a subset of this group. So that means that if we estimate this to be about 150 families have at least 3 pets, that means that the difference of these two columns represent the families that have at least 2 pets, but not at least 3 pets. So I added a little bit of text to this just to make it a little easier. So in purple we have 500 families have at least 1 pet and 450 families have at least 2 pets, which means 50, the difference between them, must have only 1 pet because they do have at least 1, but they do not have at least 2. Similarly, if 150 families have at least 3, but 450 had at least 2, well then the difference between their 450 minus 150, or about 300 families, must have only 2 pets because they do not satisfy the condition in this third bar of having at least 3 pets. And we can go on and see the rest of these. It looks like 4 pets are had by about 100 people. So that means there's about 50 who only have 4 pets. Oh, sorry, who only have 3 pets, exactly, excuse me. 50 families have only 3 pets. Now, these differences are telling us the amount of pets that a family has. So if we want to know the mode of the number of pets among families surveyed, the number that occurs the most, that's going to be this very large green bar over here. 300 families have 2 pets. So 2 pets is going to be our number that occurs the most, even though originally the 1 column was higher.